Hello students. So in the previous videos, we have discussed about Euclid division algorithm and also how to calculate HCF by using Euclid division algorithm. So we discussed some problems in all the problems in exercise 1. Now the most important thing in 10th class and also there is second topic in the first chapter, that is fundamental theorem of arithmetic. Okay, fundamental theorem of arithmetic. So what is given in the textbook we discuss and also we do some problems in this. So here, according to Euclid division algorithm, we know that a equal to bq plus r. So that is defined on two positive integers a and b. Okay, so that is a equal bq plus r. Now here you see this. You have given a think and discuss question. If r equals 0, then what is the relationship between a, b and q? Okay, so if r is 0, so you know that r is the remainder. Yes, when you are dividing a number a, yes, with b and the quotient is q, remainder is r. If the remainder is 0, if remainder is equal to 0, then what is the relation among all these a, b and q? For example, 6 is there. I'm dividing with 2. 2 3s are 6. So now we got the remainder 0. Then what is the relation between 2, 3, 6 and 6 and 3? Okay. Now see that. So here 2 3s are 6. Means here 6 I can write as 2 into 3 plus 0. Okay. So remainder is 0 here. So here now you can tell that 2 is factor of 6 and also 3 is factor of 6. Okay, means the remainder is 0, then you can say that b and q, what b and q are factors of a. B and q are factors of a. Okay, so here there is a relation. If r equals 0, then the relation among a, b, q, how can you say that? B and q are factors of a, and also you can tell that a means here 6. 6 is the multiple of 2 and also multiple of 3. 6 is multiple of 2 and also multiple of 3. So now we go to the theorem, the fundamental theorem of arithmetic. So I think you understood what is factor. Yes, means if you are able to write a number as product of two another numbers, then the two numbers are called factors of that number. Okay, so here compulsory the remainder must be 0. For your example, you see this 24 is there. 25 here it is given 2 into 12, 2 into 12, and also again 8 into 3. Okay, you can write as 2 into 12, you can write as 8 into 3. Yes, so and if you write this 8 as 2 into 2 into 2 and into 3, so this is called prime factorization. Means here we are using only prime numbers to express a number. Yes, so what do you mean by that? You are expressing a number as product of primes. Product of primes. I think you know the primes. Now already you know the prime numbers up to 100. So below 100, so we have 25 primes. So if you know those all the primes, then we can do all this very easily. So I'll write once. The prime numbers below 100 are 2, 3, 5, 7, 11. Okay, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 57, 59, sorry, not 57, 59, 61, 67, 71, 73, 79, 83, 89, 97. So here 25 primes are there below 100. Okay, so here every number can be expressed as product of unique primes. Okay, product of primes in a unique way. So that is called a fundamental theorem of arithmetic. That is also given in textbook. Let us see the definition in the textbook. That you can write and you can remember that very easily. Now see this theorem 1.2. You know that theorem 1.1 is Euclid division algorithm. Now this is theorem 1.2, that is fundamental theorem of arithmetic. So every composite number can be expressed as product of primes, and this factorization is unique. It means you can write that in is only one way. Yes, so that is unique, and apart from the order in which the prime factors occur. Means here any you can take you see this is very easy to understand. Every composite number, yes, every composite number can be expressed as product of primes. Do you know what is composite number? You know, so here the numbers which have at least three factors are called composite number. For example, see, so you know that one is not prime, not composite. Why? Because one has only factor 1. And 2 is prime number. Why? Because it has factors 1 and 2. 3 is a prime number. It has factors 1 and 3. But 4, what are the factors of 4? 1, 2, 4. So it has 3 factors. So 4 is a composite number. So that is also least composite number. Least composite number is 4. And also next you have 5. 5 is prime number. 6 is next composite number. Means here every composite number can be expressed as product of primes. 6 is there. I can write as 2 into 3. Yes, 8 is there. I can write as 2 into 2 into 2. So how do you do this? So for example, if you have a number 210. So how to do factorization? That is, we can use the division method to write 210 as factors of primes. Okay, so here we have to take 210. Now if it is even number, you know that will be divisible by 2. Yes, so this is even, so I'm dividing first with 2. If you are not able to do with 2, then you have to go for 5. Okay, if you are or 3 or 5. Okay, next 5, next 7, next 11, like that. Means you have to check with every prime number. Okay, 2 ones are 2. Yes, and here you have 1 is a remainder, 2 0 0, and here 10 is a remainder, 2 5 is a 10. Again, we can't divide it with 2, so we have to check with 3. So you know that 3, how to divide with 3. Yes, so and you can tell whether it is divisible by 3 or not. Just you should add the numbers. 1 plus 0 is 1, 1 plus 5 is 6. 6 is divisible by 3, so there are 105 also divisible by 3. 3 3s are 9. Yes, 1 5, 3 5s are 15. Now 3 plus 5 is 8, so 8 is not divisible by 3, so 35 also not divisible by 3. Next we have to take another prime number. Okay, so 2 is over, 3 is over. Can you divide with 5? Yes, 5 7 is 35. So at the ending we got again prime number, so we can stop here. So 210 you can write as 2 into 3 into 5 into 7, means the number 210, the composite number, this is expressed as product of primes. Means here this is a unique way. Okay, so you can't write as product of any other primes. This 210 you can write as product of only these primes. You can't write still within as product of any other primes. That's why it is called a unique way. Okay, and also apart from the order in which the prime factorization occur, means here the primes are 2, 3, 5, or 7 are there. You can write this order in any way. First I can tell I can do with 5. Yes, I can do with the next 7. I can do with 2. Means 5 into 7 into 2 into 3. So means the order is not important, but we have only these 4 primes to express product of primes. Okay, so here that is the fundamental theorem of arithmetic. So which problems are there? So on this, so that is calculating LCM and also calculating HCF also there, so by using prime factorization method. So we discussed that, and also we can tell that some numbers we can't express as product of primes. For example, see 3 is there. 3 can't write as product of prime numbers. So this type of numbers are called, you know that already, that is prime number. Already 3 is a prime number. That's why we can't express as product of primes. Okay, so in that case, yes, you have to write as this means 3. You can write as 3 only. Yes, and if for example say 7 also you can't write as product of primes. Why? Because it is already a prime number. Okay, so this is fundamental theorem of arithmetic is defined on only for composite numbers. Okay, that's why we should take only composite numbers. So in some cases, if you get prime while you're calculating LCM and HCF, just you have to leave them the same. Okay, now we go for what is given in the next textbook in the next. Now let us see this example 4. Some cases you are getting models from examples in examination. That's why we discuss that example also. Now see this example 3, explanation also given here very clearly. So consider numbers of the form 4 to the power of n. Consider the numbers of the form 4 to the power of n, where n is a natural number. Check whether there is any value of n for which 4 to the power of n ends with 0. So you know that 4 to the power of n. So here there is a number s and your exponent is n. 4 is a base. If 4 to the power of 1, if you take n place, if you write 1 in the place of n, we get 4. If you write 2 in the place of n, we get 16. If you write 3 in the place of 4, we get 64. But the question is, do you get 0? Is 4 power n is ending with 0 with any power of n? Means it's for any value of n. So for what value of n, this will end with 0. So you know that to get 0, compulsory the product of its primes should contain 2 and 5. Yes, so it should contain 2 and 5, then only that can end with 0. Okay, if 2 and n are not there in the prime factorization of 4, never we get 0, never it ends with 0. Okay, so here see this, if 4 to the power of n is to end with 0 for a natural number n, it should be divisible by 2 and 5. Means the prime factorization of 2 should contain 2 and 5. But here you see that 4 we can write as only 2 into 2. So as there is no pair of 2 and 5, the 4 to the power of n never ends with 0. That's not very simple. For example, the same question is given for 6 power n. You know that 6 also you can write as 2 into 3. Yes. So now the prime factorization of 6 also does not contain 2 and 5. So that is also never ends with 0 for any value of n. Okay. So here that you can write here clearly it is given how we have to write. If 4 power n is to end with 0 for a natural number n, it should be divisible by 2 and 5. So this means the prime factorization of 4 to the power of n should contain the prime numbers 5 and 2, but it is not possible. Why? Because 4 to the power of n you can write as 4, you can write as 2 square and whole to the power of n. Here what is given? 4 he is writing as 2 square and whole power n. Again he is writing 2 to the power of 2n. Okay, so here 2 is the only prime in the factorization of 4 power n. So, and you can tell that 5 is not present in the prime factorization. So there is no natural number n for which 4 power n ends with 0. Okay, that's very simple. And this you can write for any number. You know that 5 power n not ends with 0, 6 power n not ends with 0, 8 power n not ends with 0, and 20 power n that will ends with 0. Why? Because here 0 is there, means compulsory there is a pair 2 and 5. Okay, so you should answer if you get this question. And also now how to calculate prime factor, how to calculate LCM by using prime factorization method. The first exercise we discussed how to calculate only HCF by using Euclid division algorithm, but here we have to calculate LCM and HCF by using prime factorization. Okay, so now here let us discuss this example question. So the question is HCF, find HCF and LCM of 12 and 18 by using prime factorization method. By using prime factorization method. So here, first of all, we have to take the prime number 12. Sorry, we have to take the number 12 and we have to do prime factorization. 2 6 are 12, 2 3s are 6. So, and also 18. 2 9s are 18, 3 3s are 9. So 12 we can write as 2 square into 3. 18 we can write as 2 into 3 square. So what is LCM, what is HCF? Okay, so if you want to write HCF, you know that HCF is highest common factor. So here we have to check for the common basis. Common basis means here 2 and 2 are common basis. In that, here 2 2s are there, here only 1 2 is there. So how many are common? Only 1 2 is common. So that's why we have to write least powers of common basis. HCF, while you're writing HCF, you should write least powers of common basis. Means here common base is 2 and the least power is 1. So we can write as 2, and also here also 3 and 3 are common base, and we have to write 3 power 1. So HCF is 6 here. And if you take LCM, you should write the highest power of the common bases and also remaining numbers. So here highest power is 2 square and also 3 square. So 2 square is 4, 3 square is 9, answer is 36. Okay, so this is calculation of LCM and HCF by using prime factorization method. Let us discuss some more also. Now see, I'm taking another number 24 and 56. Okay, so let us see here. So 24, first of all, we have to do prime factorization for 24. 2 12s are 24, 2 6 are 12, and 2 3s are 6. 56 you can write as 2 into 28, 2 into 14, 2 into 7. So we get 24 as 2 power 3 and 3, and 56 as 2 power 3 into 7. Now very simple, HCF. Now it has the same common basis 2 and 2, and you know that least power is only 3. Yes, why? Because they have the same. So we write HCF as 2 cube. 2 cube, that is not but 2 into 2 into 2. How much it is? That is 8. If we take LCM, so here you should write the highest power for the common basis, means here 2 cube, and remaining all means here 3 is there and also 7 is there. So we can write this 2 cube is 8, 8 is a 24, 24 into 7, 24 into 7, 238. Okay, so that is the answer. So while you're writing HCF, you should write the least power for the common basis, and also LCM, you should write highest power for the common basis and also remaining numbers. Okay, so by doing practice, that you can do very easily, and this is most important thing, and you may get in 2 mark questions or in objective type. Okay, if you have given any two prime numbers, for example, and also if you are given a prime number and a composite number, let us see here on some example. For example, the question is 10 and 17. Yes, you know that 17 is a prime number. Yes, but 10 is a composite number. 10 you can write as 2 into 5, but 17, how can you write? That's you can't write as product of primes. So here 17 you can write as only 17. So in that case, HCF, what is HCF? HCF is, there is no common basis, so just you have to write 1. Common factor as 1. And also LCM. LCM you can write as product of all the numbers, 2 into 5 into 17. That is 170. So you can write 10 into 17 also. So when there is a composite number and a prime number, okay, so we call them as co-primes. Okay, if A and B are co-primes, their LCM, and what is HCM? So LCM is equal to product of them. Okay, so product of those numbers, and also HCF is 1. Okay, this is most important. If A and B are co-primes, LCM is equal to product of the numbers, and also HCF is equal to 1. Okay, this is important in objective type questions also, so you have to remember them. Okay, so here don't get confusion. When there is a composite and a prime number, the LCM is product of the numbers, and also HCF is equal to 1. Okay, if you are given two primes also same, 3 and 5. 3 can't write as product of primes, so I, because already that is prime number. Okay, 5 also. So here HCF is 1 and LCM is 3 into 5, that is nothing but 15. Okay, so here you have given some questions in the exercise, you can do them easily, and also example also that is explained very clearly, the product of the smallest power of each common prime factor and product of the greatest power of each prime factor of the numbers. Okay, so we go for the next one. So you have given some questions here. Calculate HCF and LCM of the following given pairs of numbers by prime factorization method. So the numbers are given 120 and 90. Yes, so I'll explain this question. Still, if you have doubt, you can see this explanation. So I'm taking 120 and 90. And 90. First of all, I'm taking 120. So here 260s, 230s. So you know that while you're dividing with 2, just you have to make it off. 120 off is 60, 60 off is 30, 30 off is 15. So again, I can't do 15. Yes, means I can't divide 2. I can't divide 15 with 2. So next you have to go for next prime number 3. 3 5s are 15. So 120 equal to 2 to the power of 3 into 3 into 5. Now 90. 2 45s and 5 7. 5 9s are 45. 3 3s are 9. So after 2 I have taken 5. You can take 3 also, no problem. You can do it in any way. Okay. So here what? 90 equal to 2 into 3 square into 5. So now I'm writing LCM and HCF. So here you see what is common base. 2 is common base, 3 is common base, 5 is common base. Means you should write all the numbers 2, 3, 5. For that you have to write least power. What is least power here? 1. Okay. So 1. And here 1. And here also 1. So answer is 30. Okay. Now LCM. So all are the common bases. And we should write highest power 3. Here for 2. And here 1. So what? 8 into 9 into 5. 8 9s are 72. 72 5s are 360. So that is HCF is 30. LCM is 360. Okay. If it is given only 2 numbers, you can check the answer whether it is correct or not. So just you know that already you learned in the lower classes, that is LCM and HCF. The product of LCM and HCF is equal to product of the numbers. So here, what is LCM and HCF? 30 into 360. And a 120 into 90. So here, this is 36 3s are 108. And a 2 zeros are there. 12 9s are 108. And a 1 0. Okay. 36 3s are 9 12s are 108. 12 9s are 108 and 0. And here 36 3s are 108. I think I have written. Write 90. So that is 10,800. So product of LCM and HCF is equal to product of the numbers. So you can check like that. Okay, no need checking if you are doing correctly, no need checking that. Now see this, in this one more question is also there, 37 and 49. Okay, you know that clearly 37 is prime number. So here you can write directly as 37 is prime, or you can write explanation also, no problem. 37 you can write as only 37. 49 you can write 7 into 7. So here HCF is 1. LCM is equal to 37 into 49. You can multiply and you can write answer. Okay. So here, one more question also given. Try this. Is 3 power n and 4 power m cannot taken with digits 0 and 5 for any natural number n and m. Is it true? So already I told you, if in the prime factorization, if you have 2 and 5, then that will end with 0. And you can tell that 3, in prime factorization of 3, there is no pair of 2 and 5. And also 4 also you can write only 2 square. Yes, and there is no pair of 3 and 5. That's why this will never ends with 0. Okay. Okay. So that's you can write. And also one more is there to discuss. Exercise number 1.2. Okay. So you can, first bit is very easy. Express each of the following numbers as product of its prime factors. Okay. Just you have to do prime factorization and you should write the answer. Okay. 140 is there. 270s are 140. 235s are 140. Sorry, 235 is 70. Now we can't divide with 2. We can go for 3. But with 3 also we can't divide. So we have to go with 5. 5 7 is 35. So 140 equal to 2 into 2 into 5 into 7. That's all. That is the answer. Means we are writing the 140 as product of primes. Okay. So express each of the following numbers as product of prime factors. So these are the prime factors for 140. So you can do all these numbers. And also second question, if we go for second one, find LCM and HCF of the following integers by the prime factorization method. So you have given 3 numbers also. So in the example we discussed only with 2 numbers. So I will explain the first problem, which is with 3 numbers, and you can do the remaining all. Here I have number 12, first one. 12. We have to do prime factorization for all the numbers. 12 is there. 12 we can write 2 6 are 12, 2 3 are 6. Okay, and you can stop here. And why? Because you got prime. So here 15, 3 5 are 15. 120. Sorry, this is 21. 21 can't divide with 2. We can divide 3. 3 7 is 21. So now we have 12 equal to 2 square into 3. 15 is equal to 3 into 5. 21 equal to 3 into 7. Now I'll write HCF and LCM for this. HCF. First of all, you check for the common basis. 2 is there here. 2 is not there in the 15. And for 21 is not there. So this 2 is not common base. 3 is common base for all the numbers. So 3. Initial any other is there? No. So and for that the least power for 3 is 1. So answer is 3 only. And LCM, if you take LCM, common base is only 3. You should write that for highest power. That's with the highest power 3 into, and remaining all 2 square into 5 into 7. So answer is 3 into 9 into 5 into 7. So here 3 9s are 27. 27 into 35. You can multiply and write 5 7 is 35. 35. 3 7 is 21. 11. 5 4 2 1. So that is nothing but 1245. So that is LCM and HCF for the 3 numbers. Okay, for example, I will take one example now to explain this. A number, first of all, A. So A, B, C. For this we have given prime factorization as 2 power 3 into 5 square into 7. 3 power 4 into 5 cube into 7 square. One more is given 2 power 2 into 7 cube into 11. Now for this, if you want to write HCF and LCM. So here common base. What is common base? 2 is not common base for all the numbers. 5 is there. 5 is only for 2 numbers. So that's also not common base. 7 square, 7 cube. And here only 7 is common base. In that least power is 1. So HCF is again here 7 power 1 is 7. Now if you take LCM, common base is only 7. So that's highest power is 7 cube. Okay. So highest power is cube. That is 7 cube into remaining all. So here we should write 2 cube and 2 square is there. In that we should write highest 2 cube. And here 3 power 4 only one time is there. So that is 3 power 4. And also 11 is there. And 5 also missed here. 5 cube and 5 square. What is highest power? 5 cube. So that is the answer. If there are, here we have so many numbers. That's why you can no need of multiplication. Okay, you can leave that as it is. So when you are given three numbers, this is the process of calculating HCF and LCM. So I think you can do the remaining all in the exercise first, second bit. Now let's go for the third question. Check whether 64n ends with 0 for any natural number n. 64n. So 64n, you know that the prime factorization of 64n also will not contain 2 and 5. Okay, so you can write it as 64n equal to, you know that 6 is 2 into 3. 2 into 3 whole power n. So that is nothing but 2 power n into 3 power n. So you can write as the prime factorization of 6 does not contain product of 2 and 5, product of 2 and 5. So 64n never ends with 0. For any value of n. Okay, so that is a process of writing. Okay, so here the question is check whether 64n can end with 0 for any natural number n. So here 64n, in the prime fraction of 64n, there is no pair of 2 and 5. That's why that never ends with 0. Okay, so that is the answer for this. And fourth one, explain why 7 into 11 into 13 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. You know that according to Euclid division algorithm, according to fundamental theorem of arithmetic, every composite number can be written as product of primes. Okay, so here let us see whether it is able to write a product of primes or not. This is also a very easy question. The first number is 7 into 11 into 13 plus 13. So you can see here that is sum of two numbers. So in that 13 you can take common. 13 into 7 into 11, and I'm 13 I'm writing outside. I have taken common, so you will get here 1 plus 1. So that is nothing but 13 into 77 plus 1. 13 into 78. Okay, so here 78, how can you write 78? Prime factorization is 236, 239s, and also 313s. So that's you can write as 13 into 2 into 3 into 13. Means here the number is written as product of primes. So this is not a prime number, that is a composite number. So here what you can write answer, 7 into 11 into 13 plus 13 is expressed as product of primes. Okay, is expressed as product of primes. So it is composite number. If you are able to write as product of primes, compulsory that is a composite number. Okay, for example 9 is there, 9 you can write as product of primes, so it is composite number. But 11 you can't write as product of primes, so that's why it is not a composite number, that is prime number. And if you take the next one also, you can write that also in the same way. So here we have 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. In that you can see that 5 is common. So 5 I'm writing outside here. 7 into 6 into 4 into 3 into 2 plus 1. Okay. So if you multiply all these, what do you get? 5 into 7 6 of 42. Yes, 42 4s are 168. 168 into 6. 40. 1009. 1008 plus 1. 1009. So here also I think you can't do with 3 here. 7 1 is 7. 30, 7 4 28. 20. So you can't with 7 11 11 19 19 and 19. Okay. So you can stop here. See, here also you can write the same statement. 7 into 11 into 13 plus 13 is expressed as product of primes. So it is also not composite number. So same thing you can write. This should change here. Okay. So here the both the numbers as expressed as prime, expressed as product of primes. So these are composite numbers. Okay. Thank you. Next one. Go for the next question. How do you show? So the same thing here. How will you show that this is a composite number? Again, here also we have 17 into 11. That is common number for the both. So write that. The question is 17 into 11 into 2 plus 17 into 11 plus 5 into 5. Here we have another question. How will you show that 17 into 11 into 2 plus 17 into 11 into 5 is a composite number? Explain. So to prove this as composite number, you should prove that this is also product of primes. Okay. So here given number is 17 into 11 into 2 plus 17 into 11 into 5. So I'm writing 17 into 11 as common. This is outside. Have taken outside. So here we get 2 plus here we get 5. So 17 into 11 into 7. So given number is expressed as product of primes. So it is composite number. So according to fundamental theorem of arithmetic, every composite number can be expressed as product of primes. So as this is also expressed as primes, product of primes, so it is composite number. So that is the question number 5. And also now we go for the last one in the exercise number 2, that is which digit would occupy the units place of 6 power 100. Okay, so here 6 power 100 is there. Let us observe 6 power 1, 6 power 2, 6 power 3. What do you get? 6 square, 6 into 6. How much it is? 36. 6 cube, 6 into 6, 6 into 6. That is 216. 6 power 4, 6 into 6 into 6 into 6. That is nothing but 216 into 6. 36 plus 1, 9, 1296. So here you can observe that 6 power anything that is also ending with, if you write for n times, that also ends with what? 6 means. So you can write as 6 power n is ending with 6 for any value of n. So units place of 6 power 100 is 6. Okay, so that is answer. So here the same question if you have given for 5, for example 5 power 100 or 5 power 1000, you know that 5 also always that ends with 5. Okay, 5 cube 125, 5 power 4 625. So you can write that same as this, but in some cases if you given different question, let us I'll show you one more, that one. For example, point question is this one. Point units place in product of 2 power 5 12. Okay, I'm taking 5 12, 2 power 5 12. So you can't write 2 power 5 12 as product, means here that is impossible to write. So why? Because that is very big number. Basically you have to see here what is given number is. Given number is 2 power 5 12. So we have to find the units place value. So for that, what I have to do, first of all let us observe how the powers of 2 will be. Yes, 2 power 1 is 2, 2 square is 4, 2 cube is 8, 2 power 4 is 16. Yes, again 2 power 5 we get 32, 2 power 6 is 64. You can observe here the units place are 2 4 8 6, 2 4 8 6, 2 4 8 6, means the 2 power n is always ends with either 2 or 4 or 8 or 6. But here what we have to take, we have to take a number that always ends with the same number, means here the ending with 6, then that's compulsory always ends with 6 only. So that's why this 5 to 5 2 to the power of 5 to 12 we can write as, now let's see here, 2 power 5 to 12 I'm writing as 2 power 4 into, so 5 to 12 if we divide with 4, 5 1s are 5, 4 1s are 4 and 11, 4 2s are 8, 32, 4 8s are 32. So we get 128. So here 4 into 128 is 512. Now here 2 power 4 is 16 and here power 128. Now here 16, here last ending with 6. So here already just now I told you the number is ending with 6, its power also ends with 6. So this is always 16 into 16 into 16, how many times? 128 times. This is always ends with what? 6. Therefore units place in 2 power 5 12 is 6 only. Okay, so if you have given the same question is given for 2 power 5 14, now how can you write? That is same thing, we write here 2 power 4 128. Here we get only 5 12, but again still 2 more are there. So that's why what to take 2 square you have to take. So you know that this is ending with 6 and this is ending with 4. 6 into 4 is how much? That is 24. So units place in 2 power 514 is how much? That is 4. Okay, so here this you can do for this you can find for any number. Yes, so you can, for any number you can find the units place digit. Thank you. This is exercise number 2. Take care. Bye.